So welcome back to episode number 5. Before I start, please remember we need to have 50 like in each video because your likes are like fuel for me, really. They charge me up, and that's why after coming from my office every day I can make a new video. So please like the video and let's start. So we have already finished our basics. We have already started our vectors, and inside vector we have already done 2 of the problem. Last video was little bit of theory heavy, but that was important, and in today's video also we will capture a very important topic in the theory. Probably it's a very minute one, but the difference is huge. Might be in some interview they might ask you, so I need your sincerity. So before going to theory part, let's do a simple problem from our last day's theory, and that is your you need to build a 30-bit vector can be viewed by containing 4 bytes. Okay, simple. You have a 32 bits vector, you need to truncate it in 4 bits. We need to do that. So this is what we have, but our answer should look like that. And many time we need to actually do the bit reversal in many processor CPU work, and that's the application. So we will try to do that. So here what we have, actually, see, we have a 32 bits input, and 32 bits input have 4 part of 8 bytes. Your 1 bytes is equal to 8 bits. I hope this thing is clear. So here you have 8 bits, and similarly here also you have 8 bits and 8 bits, but in together you can tell that it's a piece of 4 bytes, right? So if you just go up into the question, what we need to do, this is our input, this portion is our input. In output, see this DDDD, the last bytes or the lowest most byte or the lowest most 8 bits need to be the most significant 8 bit in your answer. So it's very simple. Actually they have given a hint also here, and we can take it out. So let me get it out of the comment section, and I can write. So this is the most significant bit of your output. So most significant 8 bits of your output should assign to the least significant 8 bit of your input. So this is the first line, and accordingly you need to do the other 4 lines. Let me do those. So 31 to 24 is done. Then our next position is 23 to next 16, so up to 17, 16, and there we will take the next significant bits. So next significant bits will start from 8 and will go up to 15, right? So so likewise you fill up the other 2 lines. I hope we have divided perfectly. If then the answer is this, so we should get a success message. So it's quite easy, and it's here they are trying to let you apply the part select application of vector. Here you are selecting the part of the vector, right? And as suggested, it's a success. Okay, so here you need to see one thing, like how they are actually giving us input. These are your input, this like input bits, these are the output yours and what they are expecting. So here what they are doing, see, here they are giving 1 2 3 4 5 6 7 8, right? These 8 are written in decimal format, right? 4 2 5 3 5 1 2 1. But this decimal, for example 4, how you can write a 4? We can write a 4 using 100. But how you can write a 5? It's 101. So here we can use 3 bit to write one decimal number, but what here they are doing, they are actually using 4 bits to write one decimal number. So here you have 8 decimal number, you need 4 bits, so 4 into 8, it is 32 bits. So that's why your in is 32 bits and then you are reversing it and you are getting this output. In output also you might be a little confused how it is coming. So in output, you remember, right, we are taking 8 bits or 1 bytes at a time. So 8 bits will contain, here the lowest significant 8 bits or 1 bytes are 24, right? 1 is of 4 bits, so 2 and 4 need 8 bits, right? So this 24 is going here, see here 24, then next 35 is coming here 35. So we are doing the reversing. So likewise you can see your waveform. Seeing waveform is also very important, because in future we need to do verification. So during verification you need to see the waveform, and then by watching waveform you need to find out that, hey, my answer is correct or not. Here for our ease, they have already like they are comparing both of these two and they are giving us mismatch 0, so it's great. But in future in industry we won't be getting this liberty. We need to, like, we ourselves need to find, is it okay or not, is it a perfect answer or not. So that's why seeing waveform is also very important. So keep a look here. Okay, so let's go to the next problem, and next problem is your vector gates. It's very important. Actually, one of you have asked me one question, and that is sometime in one of my video in second episode, I think I was using n% 2 time a plus b to make a AND gate, and in my third episode probably I was using only one n% and I was saying it's the AND gate. Both have the differentiation, but in our second episode and third episode we haven't seen any differences, because those time our a and b are consist of only 1 bit, right? But with the introduction of vector, we know that, hey, our a could be of more than 1 bit. If I write like this, where 3.0a, then our a is of 4 bit, right? And the same time if I write the next line 30b, and then I write a n% b, and I write a n% b, then both will give us a different answer. And that's the main trick here we need to understand today from today's video. So if you use only one time n%, then it's a bitwise AND, and if you use 2 times, then it's a logical AND. So what does it means? For example, your a you have taken 1 0 0 1, and b you are taking 0 1 1 0, 4 bits, right? We have defined it for 4 bits. So bitwise AND means we will just take this bit 1 and 0, end of 1 and 0 it's 0, 0 and 1 it's 0, 0 and 1 it's 0, 1 and 0 and 0. So our answer, if I assign this thing to probably C, then our C will also be of 4 bit, and answer will be like this 0 0 0. But at the same time, if I use this definition, logical AND, then what I'll get? Any guesses? I will get only a 1 bit answer. As name suggests, it's a logical AND, right? So logical AND will see this whole a as a whole. So is this a 0 number? No, it's not a 0 number, it's a non-zero number. It's a 1 0 0 1. Perfect, it's a non-zero number. Then b, it's a 0. No, it's not a 0, it's a non-zero number, 0 1 1 0. So if two non-zero things are getting AND, then what would be the answer? Answer would be true only always. So my C will be 1 only. I'll get a only 1 bit answer. If here your A have this one 0 0 0 0, then our C will become 0. But the main conclusion of this discussion is that if you use a logical AND, then irrespective of bits number, your A and B, the answer will have only 1 bit. Answer would be of only 1 bit, true or false. If your operand here A and B are non-zero and you are doing AND, then you will get a non-zero, like true answer 1. If one of is 0, then you will get a false answer, which is 0. And here if you do bitwise, then we will consider each bit at a time. So that's why it's very very important. And I have taken an example of n% and logical AND, but it's true for OR also. So if I use only one this symbol, then it's a bitwise OR. If I use 2 twice, then it's a logical OR. And the same thing actually they are explaining here. They are saying you have A of 3 bits, you have B of 3 bits, and you need to do A and B first bitwise OR, then logical OR, and then bitwise NOT inversion, and get the answer. So we're gonna do that thing here just to make you like comfortable with this diagram. Here what we are doing, your A is of 3 bit, right? So 3 bit, for example 0 1 0, and your B is of 3 bit, for example 0 0 1. So bitwise mean what I'll do, I need to have my 3 OR gate, and I will push each one bit at a time. So here probably I'll give A0 B0, here I'll give A1 B1, and then I'll give A2 B2, and then I'll get the answer, and answer will be stored on C0 C1 and C2, right? So here instead of C it is out or bitwise, and here C, because we are doing bitwise operation, so that's why we are having the same number of bits what our input are defined. But anytime we wanna do a logical OR, then we only need a single bit output. Logical, we just compare the whole number, is it a 0 or not. If it is 0 0, it's OR, right? So if one of the number is non-zero, then answer will be true, 1. So first let's do one thing, we will assign. So how we gonna do it, we need to take each bit at a time. Here your out bitwise have 3 bits, so we need to take each bit at a time, and we have already studied this, right? Part select of vector. So how we do part select of vector, let me show you. Bitwise, so part select is this. So first 0, I'll select 0, and 0 will take A0, and what I need to do, I need to do bitwise operation. So I'll take single one and B0, and let me complete this one. So I will do the same thing for other. So our second bit will go to second of A and second of B, and the third one will go to third of B and third of A, right? Now here I have one question, but for now let me hold the question, I'll tell you afterward. Okay, so that's one thing, and then we need to do this one, logical one. So for logical one I'll write assign, and then I'll just write A, and for logical I'll use it twice, and then B, and then semicolon. And then we need to do each bit, we need to inverse them. Like here you won't be seeing it, but see here what is happening. Here our output of this NOT gate, we are having a 6-bit number here, right? But here our input are of 3 3. So as you know, NOT gate only need one input. So here actually we have 3 and 3 6 input, right? So 6 input need 6 NOT gate, and 6 NOT gate will have 6 output. So that's why our output is here is a vector of 6 bits. So we will do that. So we will write, what's the output name, out not. So out not will have a 0 component, right? And before that I need to assign, yeah, let me copy it how many times, more 5 times, because okay, copy it, then the second bit, and then the third bit, fourth bit, only one input one output for NOT gate, so it will go to A0, then next will go to A1, and we are missing something, the inversion operation. Okay, I hope we have done everything perfectly. So let me submit it and see the result. Here also after result coming, try to read the waveform, how waveform is coming. Now it's all simple, but when we'll have the complex circuit, we need to keep on seeing the waveform. And we got a success message, right? So yeah, please read the waveform, how it's coming. So here what they are giving the decimal value here. So 1 2 3 4, but decimal number will come in bits. So your A is of 3 bits and V of 3 bits. So in 3 bit we can represent decimal number up to 7. So that's why they are giving here, see, 0 1 2 3 4 5 6 7, and for other they are giving 7 full, then 0, then 1, likewise, to get all the combinations, right? I hope you are getting it. And then the answers. Now my question is that I said we need to do bitwise OR operation, but if I do a logical OR operation here, will it change my answer? Will it create any error here? What your take on it? So as I said, if it is only one bit, then doing a bitwise or doing a logical imply the same answer, right? So if we use a logical here also, then we will get a same answer, we will get a true. So let me do it and see, we got a success message. So that means this exercise is only to let you know the difference between the logical and the bitwise operator. But as bitwise operator will work on with only one bit only at a time, so that means that time you can use a logical operator. But same time, for example, here we need to do a bitwise a logical operation here, right? But during a logical operation, if I use a bitwise operation, then what will happen? See, we'll get an error for sure, because here we are trying to do a bitwise operation, 3-bit operation, which will result a 3-bit answer. But our out or logic, if you see the definition of your out or logic, we have not defined any dimension of vector. So if we don't define any dimension of vector, it will by default will be a 1-bit number. So this will result a 3-bit answer, but our output is a 1-bit number. So that's why we'll get a result, but result will be false, and we'll also get a warning. And in the warning, it will show that, hey, your result got truncated because you are trying to assign 3-bit number to a 1-bit number. So anytime you need to use a logical operator, never use a bitwise operator. But in the place of bitwise operator, you can use a logical operator, no issue. See, we got an error here, and if I go down, then here they are showing in the line number 11. So we can go to line number 11. Line number 11. So here we done the mistakes, right? So in the line number 11, what happened? Truncated value with size 3. Size 3, your A or B of size 3, to match like the result of their bitwise operation will be of size 3, and which we are trying to a target of 1 bit. So anytime you find such kind of error, you just remind yourself that this is the error you are doing. Okay, so I hope this is also clear. So let's go to our third problem for today, day 5. If you haven't liked it, you still have the time to like. Okay, so here what they are trying to do, they are saying, hey, you have a 4-bit input, right? And you need to feed those 4-bit input to a 4-bit OR gate, 4-bit AND gate, and 4-bit XOR gate. I hope it's very easy for you. If not, I'll help you, don't worry. If easy, you can skip your video now and try out solving it. So what we need to do, we need to, in is given, so this is your in. So first we need to partly select it, which we know already how to select a vector partly, and then we need to give this thing, apply this thing to the respective gates. So let us try to do this. So what I gonna do, so I have one output first, and that is the output of my AND. So output of this AND should go to your 4 input bytes, right? 4. So I need to partly select them. So to partly select them, what I can do, I can write in 0, and then let me copy it. Now tell me one thing, just while ago I said we can use a logical and bitwise. Here what we should use, we can use anything, right? These are bitwise anyway. If I write anything, like for example here AND gate, so if I write here one AND, that means I am doing a bitwise AND between this and this fellow. And if I write n%, then that means I am doing a logical and between this and this fellow, but they are a single bit only. So we can use n person or n person, both are same. I'll show you how result for both are the same. Okay, for now let me use only bitwise operator here, and then comma. Let me do the same thing for other two output. So it's done, and let's submit. Now we are using bitwise only. I'll show you with one using logical, but you will see we will get a success message. So and see, we got a success message. You will see the graphs, don't worry. So let me do one thing, use only one as logical one. So let us try if we get any difference in the answer, and see, we got a success. So that means I hope everything, like from today's video at least, you will never have this question, what does bitwise and what does logical operator means, right? So now is the time to give you answer for our last episode question. And the question was the difference between net classification and variable or register classification. So nets, as we are using here, whyRD is a net type only. So this is concurrently driven. Anytime it can't hold anything, it have no memory element, right? So if you tell, like in our combinational circuit, in our sequential circuit, there are many occasions where we need to hold a value, right? We need to hold a value, and if and only if something is true, set is true, reset is true, or some clock is coming, then only the value of that particular data type will change. But for a net type, we can't do that thing, right? So that's why we have the another data type which called register or variable type. But what's the use of net type? Net type, because it can very nicely replicate the hardware behavior. Anytime in hardware we connect two things using a wire, simple wire, then that time both the two things are concurrently driven. They are not waiting for anything. If one side of the thing change, then the other side for sure will change. There is no memory thing to hold them, right? So that's why we have a net type and we have the register type. And for sure in future problem we will see the use or application of both of these type. For one net type we are seeing it, right? We are not using any clock, nothing, no condition, but things are getting changed. So that's the application of net. But you will appreciate them more when we use both the type classification together. So wait for that. And question for today is again very important in your interview scenario, and that is, what's the difference between behavioral and structural description? You need to form your answer in your own word. Don't search. You can search, but after searching, form the answer in your own word and write down in the comment section, because by this way you are helping yourself. First thing, because you are searching, you are writing things here, and by this way you will retain this answer for a long time, right? You are also motivating your friend to do the same thing. So you are helping me also, because if you keep on commenting, keep on liking, then YouTube algorithm will see, hey, this channel is really creating the engagement, right? And if you do this thing, then YouTube algorithm will throw this video to many more participants. So by this way you are helping many more unknown people also. So that's why please keep on commenting the answer. If you know also, if it's very easy also, but please comment it down. It helped me, my channel, our channel a lot. So I'll see you in our episode number 6. Till then, tata, bye bye. Keep smiling.